Deep in the rainforests of Borneo, a worker ant is locked in combat with an intruder. It bites down. It curls the rear of its body forward. Then it makes a move it cannot survive. Its body wall ruptures. A bright yellow glue-like secretion spreads across both insects. The attacker can become trapped. The worker is done for. And somewhere behind it, the colony gains time. This is Colobopsis explodens, one of Southeast Asia's exploding ants. Before scientists formally named the species in 2018, they had a simpler nickname for it: Yellow Goo. The name came from the bright secretion released by certain small workers. These ants live in rainforest trees, where workers patrol leaves and branches. But not every member of the colony carries the same defense. Large workers have broad, plug-shaped heads. They can block narrow nest entrances like living doors. Smaller workers do something far more extreme. Scientists call this behavior autophasis, self-destruction by rupturing the body. Inside a small worker, the reservoirs of the mandibular glands are enormously enlarged. They begin near the jaws and extend deep through the body, storing the yellow defensive material. When a fight becomes serious, the ant grips its rival, curls its abdomen, and contracts its muscles with enough force to tear its own body wall. The gland contents are squeezed onto the opponent. There is no flame, no smoke, and no explosive blast. This is not a grenade. It is a one-use biological glue trap. That distinction matters, because the secretion may not stop enemies mainly by poisoning them. In laboratory tests, the naturally expelled material and its major compounds did not cause rapid death in the insects researchers tested. Its adhesive power appeared to be the more important weapon. The sticky secretion coats legs and body segments, restricts movement, and can leave an opponent unable to continue the attack. The ant does not blast the enemy away. It turns itself into the trap. But the yellow goo may have another job. Researchers found that the secretion inhibited the growth of some microorganisms. Small workers can also release tiny droplets near the base of their mandibles without rupturing themselves. That suggests the chemistry may help influence the microbial world around the ants, not only defend against rivals. So the same substance may serve as a last resort weapon, and possibly as part of the colony's chemical maintenance system. The full story is still being studied. Why would a defense this costly ever evolve? Because an ant colony does not work like a crowd of unrelated animals. Workers are close relatives, and they usually do not reproduce on their own. Protecting the queen, the developing young, and the rest of the colony can preserve the workers' shared genes. At the scale of the colony, losing one worker may be worth it if that sacrifice stops a larger threat. It is a brutal trade. One life, exchanged for the safety of many.